1.5 hours in total. So 1.5 hours in total. Grab your drink if you need to. And after this introduction and beginning session, we will have the presentation from Davide Mottin, Aarhus University, like for about 50 minutes, and followed by a Q&A session for 30 minutes. Take that as the notes. And then we will have a closing session at the end. And yeah, we are extremely excited and honored to welcome our speakers from 4 universities. We have Davide Mottin, Associate Professor at the Department of Computer Science, Aarhus University, Denmark. Davide is here already. Hi, Davide. Thank you for joining us. Nice to meet you, Davide.
Thank you for inviting.
Also, yeah, thank you too. And we also have Sarah Graham, the student admission from Aarhus University. And here we have Sarah. Hi, Sarah. And she also will stand by if you have any further question about any inquiry about joining the Aarhus University for your future studies. Okay, thank you to Davide and Sarah for being with us today. According to the agenda, let us start the first session with a presentation from Aarhus University, and I will give the floor to David. The floor is yours, David.
Thanks a lot, and thanks for inviting me. I'm very happy to present or to represent Aarhus University here, especially the computer science department. So I'll just share my presentation. I think it's visible, right? Okay, perfect. Yeah, so this is a halfway serious, halfway funny presentation, but I think it's also interesting because this is a very high level and that allows you to understand some of the things that we do in research, but also there is a lot of teaching involved. So to arrive at this point, to enjoy a bit of research, there is a lot of learning curve. The important information, so yes, I'm an associate professor at the computer science department. That's in my back. There is basically, that is the building of the computer science department. And I teach mostly data mining, machine learning, so all this kind of data analytics, but also some part of data management. We're very happy if you want to ask questions. So we have a master open for international students, and from the next year we will also have a bachelor completely in English for bachelor students, so international bachelor students. A bit about myself. As I said, I'm an associate professor. I am a part of the data intensive systems group, and you will understand that basically has to do with data. Before I was also an assistant professor in the same place, and then I spent a bit of time traveling around. This is a picture of me a few years back. I love mountains. So unfortunately, that is not, Denmark is not the place for mountains, but you can find a lot of other lovely places where to be, and nature is also really, really good. But let's go a bit back in time. I like to have this backward. And this was a movie that came out in 2004, and I was, this is maybe some of you recognize this is iRobot. And in that movie, there was a dystopian, kind of a dystopian world where AI, so the artificial intelligence, will take over the world. These were not, so this is one of the protagonists, and this is one of the good ones. So this AI is evil, is basically a supercomputer that is able to control a lot of aspects and control all these robots also. But this one, that actually fight against this evil AI. And I mean, the purpose of the AI is to make the world better. And somehow my talk goes in the direction, does it make the world better? Yes, but we also need to understand some of the risks. And funny enough, so when I started, so this is part of my story, basically. In 2019, I started in the computer science department, And there was this kind of AI, right? So this is a very different from what we have seen in the movie. We could ask questions. So what is the weather today? And well, let's say that this has a sense of humor. If you are in Denmark, well, today actually it's not like that. Today is rainy, but if it is sunny, definitely enjoy the weather and stay outside. So one other information, perhaps, where is Aarhus located? Well, Aarhus is located in Denmark, more specifically in the Jutland Peninsula, and it's a fairly alive and nice city. Actually, it's not in a normal city, but it has everything that you need. And if you want to travel a bit around Europe, for instance, can you recommend me a city like Aarhus in Europe? Well, this is where the AI at that point was failing. And it was failing because it was asking for something a bit deeper here. What is actually a city that is close to Aarhus in some sense? So what resembles Aarhus? That was not very clear. And that was the answer. So here is what I found for a city like that. Well, fast forward. I think every one of us now currently have used the ChatGPT, for instance. There is Gemini, there is others, right? So these are called the large language models. And it's a form of AI, very advanced, in which you can ask, ChatGPT, can you recommend me a city to visit like Aarhus in Europe? And ChatGPT will answer you. Of course, that's Gothenburg. You can go to Gothenburg in Sweden, and it actually says Aarhus is a vibrant cultural scene, picturesque waterfront. Right. So this is exactly what I was expecting at that point in time, and rich history. And then you have Ghent in Belgium, Bergen in Norway. By the way, if you come and visit Aarhus, these are all the possibilities and possible cities that you can also visit around, right? So Europe has the luck of having a lot of things in a very compact space. Cork in Ireland, and whatever, you can go around, right? But these are actually fairly good recommendations. Of course, I'm a researcher. And the questions that I was asking before was my main drive and my main driver for research. So my reaction was more similar to this. Oh gosh, not again. So this has been done already. But is it really true? So is it really true that finally we have an AI that can do everything? So is it worth studying computer science? Well, I would say yes. And let's reformulate a second, right? So let's stop for a second and say, do you remember ChatGPT, the internet, which appears in an episode of the IT Crowd? Many of you might not remember, but if you want, actually, this is a very nice show to look at, which is a British show. And there were these guys that were making fun of a lady that was the manager, was absolutely not aware of anything about computers. So in the IT, so she was managing the IT department, and I said it appears as a giant balloon. This is wrong. This is wrong. So and ChatGPT, yes, ChatGPT tells me yes, this is true, and it crafts a story that actually looks reasonable. I can read it, and it's a story that makes sense, right? So it is in that episode, and blah blah blah, and they are making fun of it. So it makes perfect sense. Unfortunately, this is what internet was in that episode. So they were showing this box with a single light, and they were saying, "Oh, this is the internet." Okay, so there is still space for us, and of course, my reaction was very different, right? So I knew that there was some space, so I said, "Okay." There is something that we have to do. So the purpose of my talk today is also to inspire you, because we are inspired by what are the challenges of computer science rather than what is already existing. So of course we like what is already existing, we like studying and understanding, but we like new challenges. And I want to remind everyone that intelligence is actually an accident of evolution and not necessarily an advantage. So all these models also that seem so sophisticated might not be to our advantage. So we need to understand when they work for our advantage and when not. And this was actually a quote from Isaac Asimov, who is the one who wrote the book I, Robot. By the way, the book which is very different from the movie. So the question came into my mind. And why are we having wrong answers? Well, let's go back. What is an LLM? What is ChatGPT? Well, it's basically this. I will simplify it to you very much. And it's a bunch of documents. Imagine that you have an enormous library, basically as big as internet, and you bunch it inside and you crunch it with a computer. You have what is called a transformer model, which is it's a fairly simple, once you basically, if you finish your education, or you are in a computer science education, it's very simple to understand, but basically it captures somehow the ordering of words and what word comes after another, or what word is missing between two in a sentence. So what is the missing word? So if I give you a sentence, this is basically sequence. So basically it is able to predict the next word in its speech. And that's why they can create answers that look reasonable. Then you put together something that is as big as the Google computations or OpenAI computations, that is enormous servers. You wait for a month, basically. You get bored and wait for a month, and then this comes out. It's not as simple as this, but this is basically the recipe. Okay, so this is what we think LLMs are, but what are they? Okay, let's see if we change a bit what we give as an input. If we give as an input, for instance, a bag of trash, you will still have your transformer model, you will still have a server room, and a huge amount of computations. By the way, it cost billions of dollars to train GPT-4, right? And it takes 30 days, so 1 month or more of computations, because it has a lot of these. So this that you see here, that is the transformer, it has a lot of them, and enormous. Well, if you give trash as an input, what you expect is trash as an output. So basically, trash in, trash out. So, but in between these two worlds, in between having a very nice set of documents that are very polished, there is what internet is. Internet is a box, we know, with a light. That's already. Well, in practice, internet is a set of informations, some of them right, some of them wrong, some of them correctly written, some of them deceiving. So it's a bit of everything. And what you obtain as an output is I give the internet and I obtain a giant balloon. So what happened? It happened that what we have done indeed was to take something that is imperfect and create something that is again imperfect. And that's reasonable. Let me show you something a bit different, right? So can I actually capture some qualities of these LLMs, which these are large language models? Well, ChatGPT is basically something like that, right? So I ask, what is Denmark? And it will reply to me, Denmark is a country located in Northern Europe. It consists of the Jutland Peninsula and archipelago, blah, 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 and all sorts of interesting information about Denmark. That's cool. However, what is the representation that this model has? So what is a large language model inside, in practice, in mathematical terms? Well, imagine that you know a few words and you put them in a sheet of paper, so just a piece of paper, and then you put them there, and then you create a link. If these two things are close enough somehow, they are, imagine that these words are on your table, and if they're close, you put a link. And so you have, for instance, the connection between Denmark and Copenhagen, because you can see it here. Imagine that this was a document that you have given as an input, like a Wikipedia page, and then Denmark and Copenhagen, you assume that they are close, and Denmark and Northern Europe, you assume that it is a bit far, for instance, to have Denmark and Luke Skywalker. Reasonable, right? So these two things should not stay close together. So in some sense, your model, so your complex AI, is learning how to put together things that are similar and put far away things that are not. To me, this looks like what we call a network or a knowledge graph. So a knowledge graph is something that exists, it's data that we have somewhere, and in which we have, for instance, Denmark, we have this information with like nodes, so like basically bubbles with names, and connections that have some label. So for instance, Denmark, capital, Copenhagen. So this is what exists. And imagine that we connect all of them together in some sense, in some ways, or things that are connected should be connected, things that are related should not be connected. So the funny thing is that from what is on the left and what is on the right, there is not much difference. This is what an LLM is, and this is what exists. So this is what we have done with data manually. For instance, in Wikipedia, we have done that for years. And we know that what is on the right is definitely better than what is on the left in terms of be sure that the information is correct. All right. So I started asking myself some questions. Can I trust? Can I say, so if I have these large language models and I know nothing, can I trust that Denmark and Northern Europe are actually connected? Can I trust this similarity? But I also have to do one step, right? Remember that if I put trash as an input, I have trash as an output. So is this what I have in the original data even correct? If these two are correct, I can somehow use them together. And that's one way that we are studying. It's still not there yet. I personally like graphs. So this is this abstract representation. So what I also teach at Aarhus University contains this part inside. And I like graphs everywhere. So, and people that are completely relevant said so. So graphs are everywhere by Rafi Bank and Sid and Agrava. I don't know. I have no idea who these people are. And we know that some very famous people said graphs are everywhere. The first question is this fact correct? And it's one of the two questions that I ask. Okay, remember something. Remember that data can be wrong, arbitrarily wrong. And so what does it mean? Well, let us assume that we are a journalist and or a scientist. So these two people ask questions. A journalist that asked a question, what is the capital of Denmark, right? So it has to basically build its own news article, goes in one of these LLMs, or in these smart devices that will become smarter-ish because of these large language models, such as GPT and so on, and the like. We can look, for instance, in our data and check what Denmark, capital of, and okay, fair enough, we can find this relationship, and they say, look, this is clearly Copenhagen. Great. One thing that you might not know is that this type of data is absolutely ubiquitous, and it's ubiquitous in many, many different applications. So many companies are actually interested in this type of data. But nowadays, they're even more interested because there is this game that we can play between large language models, so ChatGPT, and these knowledge graphs. So they're called knowledge graphs. And then we have, during COVID, there was, for instance, COVID graphs. There are things, knowledge graphs. Usually when you see KG's knowledge graph, and it's for fact checking. There is biomedical or medical knowledge graphs. There is more encyclopedic knowledge graphs, so things that like Wikipedia, but made like a graph, like a network. Now, the problem is the following. What if we ask the question, is Johnson's vaccine used in Denmark? This you might not know, but at some point it happened that during COVID they decided, no, Johnson's vaccine should not be used, so it should not be used. Unfortunately, the data might, if you don't update your data, it might get wrong information. And this is what happens, right? So if I look at the data and I ask this question, I will get an answer. So exactly as I was getting an answer from ChatGPT before, also the data has the same problem. So, and my point here is the data also carry problems before even using these complicated machine learning or artificial intelligence models. Well, needless to say, this is an enormous problem. This is an enormous problem. So again, if you come, or if you want to enjoy the vibe of the computer science departments, we are looking for these problems under many different angles. And these are just a very small subset of problems that we look at. So misinformation is a problem. And it has been seen, for instance, with many different, so many sources pointed out that there is a rapid spread of misinformation. Again, if we use a machine learning model that has been trained on wrong data, what it learned is wrong facts. That's a problem. That's a real problem. So by studying computer science, we can also look at this problem from the computer science point of view. By the way, Denmark, this is, of course, this is Danish. You're not supposed to understand. How can we fight this information is written? How can I find misinformation in our environment somehow? All right, so this is a big problem. And the big problem is that, for instance, Denmark is actually a good place where people trust what the news says. That's not true everywhere. I have found out this, so many of you I know are from Indonesia, there are people from India, and you know that in your countries, the trust of information is much lower. If you ask yourself, are we worse? We Italians, are we worse? Yes, we are much worse. If you are in Greece, you probably believe more to a piece of paper that you find in your candy rather than the news. Basically, this is what it says. So 20% of people believe in what is said. That's a bit sad, right? So, and of course, there are some effects here, but even France is in a very bad position here. And just to put something, why we don't trust, this was a mainstream newspaper written in Italian. I translate it for you. It says, in the Ukraine war, the Russians were out of ammunition, and they were using the fingers for fighting. I mean, that doesn't require a huge effort to understand it. That's wrong. Nevertheless, the main newspapers online and also physical newspapers in Italy spreaded this, and it was clearly wrong. Of course, I don't want to enter absolutely any political issue here. I'm just pointing out that there is a fact that if you use common sense, it's hard to believe. What do we do? Well, I teach data mining and machine learning. What is data mining? Data mining tries to find something that is relevant in the data, such that perhaps we can say something new or something surprising. And for instance, one thing that we can do is to cleaning with what is called rules. I don't enter into the details, but what is a rule is something that tells me, so if something is part of Scandinavia and is a country, so that means that this is a part of Scandinavia, but it's also a country, then it should be a member of Schengen. And if I go in the data, sometimes this is not true. So it's not available, that information. But if I apply this rule, this is a rule, I call it a rule. If I apply this rule, I can actually add an extra edge here. So I say that Denmark, which is part of Scandinavia, then it should also be a member of Schengen. Whether this rule is true or false, it's another big issue, but that's one of the things that we were actually asking ourselves. What if your data has problems? So how did you find these rules? Well, there are two ways to find these rules. Either I write them manually, so there is an expert telling you what is actually true and what is false in your data, which is very precise, it's a very nice work, but it's super slow and expensive. Imagine that this data has millions, billions of nodes and connections. The other way is automatic. If I do it automatically, it's fast, but it's very imprecise. It could lead to errors and rely heavily on the data quality. So if the data is bad, again, this cleaning method is bad. So it's a chicken and egg problem. Whenever the data is bad and I use a data-driven approach, I will get the bad results. But I cannot validate because it's all, my assumptions are all based on the fact that the data is good. So how does automatic rule discovery? This is a kind of a lecture. So this is something that I would present in a master because they are quite advanced techniques, but feel free, you can ask questions, of course. I don't enter into details because it would require me a proper lecture, so like 1.5 hours only to explain. By the way, when I teach, it's 3 hours that I go on and talking and rambling about the different algorithms. But what we basically want to say here, how do I do it automatically? I measure how many times the right part of the overall part of is a country member of. So these basically 3 facts together, how many times they appear compared to the fact that they appear only as Scandinavia and is a country. So that means how probable is that I find these all of these 3 things together, given the fact that I have only found the left part here. In other words, I'm saying this is a relative comparison. It's a relative comparison because I want to say this is important relative to this first fact here. This first fact here is like an hypothesis, right? So I'm testing that. So if I find this, whenever I find this, then I should find also this. That means that I want to test, if I only find this, is it also true that I find the rest? Okay, this is a very common way. You can find it in very traditional algorithms, but this allows to just say, go around in my data and find out all the rules such that this specific, what is called support or measure, is greater than a certain threshold, is greater than a number that I decided to be. So I decided that if a rule is significant, it must have a support of at least for 40, 60, 70%. I don't know, I put a number. Now, there is a problem though, when you deal with knowledge, that this measure here does not distinguish when this edge does not exist because it is false or because we don't know, right? So there are 2 different cases. Either someone forgot to put in this fact, or it is simply wrong. Again, this I managed to explain somehow, but this is a bit more complicated. What these people says, okay, do not only test for things that are things that don't exist, test for things that don't exist, as long as there is nothing that contradicts that it doesn't exist. More or less. I mean, this is what basically they have done. So the top part is exactly the same, it's the bottom part that changes. And this is still very good, but they're very inefficient. And still, we don't know exactly whether these facts exist or not. Long story short, there are a lot of these algorithms. They all do similar stuff. They just define a way to find these rules in an efficient and in an effective manner. But none of the method think about, oh, look, if the data itself is not valid, so even by doing a modification on the confidence, still I have problems. So what we actually wanted to do at that point was, okay, look, and that's where the work of a researcher starts. And is, okay, look, we can do both. We can actually put them together. How? Well, I don't do manual completely. I don't do automatic completely. So I do automatic only when I'm sure that some user, at least someone, told me that it's correct or not. So the general idea is the following. Let's first generate everything that matches the first part here on the left, right? So again, remember that the support was a comparison between all these three facts together and the fact that only the left part is true. If I do that, so if I just match this, I obtain what is a set of triples. I obtain a set of results. That's cool. So how do we include? So our conclusion was, okay, look, if I can show a few of them, of these facts here, a significant amount of this, whatever significant means, to a user, the user can tell me, so assuming that the user is an expert, can tell me whether they're true or false. And this is good, but we still need some sort of a learning. So I cannot just ask all the users to evaluate all, because I go back to the manual process. I want to ask as few questions as possible, such that I can improve the quality. Again, it seems a chicken and egg, but the problem becomes easier. So what I do is, okay, I give the output of my rule. I ask a domain expert, and then the domain expert tells me, okay, this thing that you have given me, of one of them, I just select one of them, it is true. Good. What I do is that, okay, I first transform this in something digestible to a computer. Computers understand numbers, so I transform this in basically in a set of numbers, which is what is here in embed. So that means put it as a set of numbers or vectors. I do some operation, and then I basically have this, what I call an instance, which is a triple. Robin Williams produced Mrs. Doubtfire, and a label, true or false. What I have in the middle is a model here, a very fancy model, or not a very fancy model, but it's a model that is able to learn from the user input and adaptively change, so keeping changing. Not only, this model is also able to select the next triple to present to the user. So the user doesn't have to evaluate all of them, all of this. They just has to, a few that this very, very specific model can select. And we keep looping. We loop for as few times as possible. But what is few? So again, this is black magic, right? So this is again resorting to some sort of a machine learning. But this machine learning has some good characteristics. Again, oops, something happened in the presentation. All right. Oh, okay. So there is some. Okay, what I want to highlight here is that how do I transform a set of a graph, so a network, into into points, basically, because then the computer understands the numbers or points. So points, fine. This thing, not fine. Well, there are some methods. There are some methods that are called embeddings. There are also machine learning methods, which they basically do some transformation that is able to say, okay, for each of these nodes and for each of these relationships, I associate it to a set of numbers. And this set of numbers have good properties. I'm sorry, again, there is probably an implicit this is not important. I want to show you what is actually the model. And again, these are once you know a bit more of machine learning, or once you know a bit more of artificial intelligence, or you already know, you can move around and play a bit with what exists and modify it. This is called the Gaussian process, and this is the following. Remember that I want to learn or know what is the user preference, or not a user preference, but I want to know whether the user will tell me, is it true or is it false? I would like to learn what is the implicit model, what is the user. And I represent a user as a set of potential functions that tells me if I give a triple, okay, if I give a triple, it will tell me, so like Copenhagen, it will tell me whether it is true or false. So it is high, somehow the score, if it is true, and low if it is false. This model works in a very funky manner, and what it does is basically tries, the more you ask this model, so first of all, it's not only telling you what is true or what is false, it will tell you how certain it is. So in order to say what this point that the model has never seen, it will tell you, okay, it is probably true, but I'm very uncertain. So at the second iteration, what we do is basically we take another point in which the model is very uncertain, but which we have the possibility to reduce the uncertainty as much as possible. That's a bit of a technicality, and it is basically this function here. Okay, so how did we evaluate this method? So again, when we do some stuff or some machine learning, we need to evaluate what we do. In our case, what we did was to take basically a set of rules that we have mined with the methods that we already had, and manually annotated. So here there is a manual annotator, because in the end we need to prove the quality of our model. By the way, this data set is available and so on and so forth, but this is mostly some propaganda. The idea is that we have tested on a large number, so we know that, for instance, in the knowledge graph, this rule appears 9 times. But if we take only the left part, 24 are correct out of 99. So you see that these numbers are very different. So that means that even these knowledge graphs that we had as an input, they were not perfect to begin with. They were very much not perfect. And these numbers, so for instance, here, the knowledge graph gives us 1,000. All of them are correct, over 1,000. And that can happen. But for others, it's not true, right? So so here we had basically some annotators that were some students at that point. We made this as a kind of a user study, and we produced this data set that is now available. And this is another thing that we like to do in science, is to improve the knowledge in general. So to allow other people to work on the same problem or similar problems. So we like to create these data sets that can be used. And that is very important for machine learning, where you don't know exactly what is going on. What we typically show is also, okay, look, what do we do? Well, we are better. This is our method, and you see that this is a method with using some technology, and the same method using some other. This is a baseline basically method. We also used something much older, which is active learning, and we show that basically we are much faster and better somehow. This is how many you can you can read these as the percentage of questions that we need to ask. So how many questions do we need to ask to the user in percentage based on how many results we have? And of course, we say that we are better, but not only. Remember the standard confidence, right? So the confidence was computed on the data. Now, if we compute on our data set that is completely clean because we have the ground truth that we created through manual annotation, we can see that our method actually is much better. Why? Because the standard confidence doesn't change, right? So it doesn't know anything about the user evaluation, so it is constant. But our method, after 10 questions, 20 questions, already reduced by half the error. So the standard confidence was off as a measure, as a number, basically half of the times. That's not good. All right, this was the first problem. The other question was, okay, look, can we trust a similarity? Well, let me again recap what is knowledge graph embeddings. Graph embeddings are, you have a graph, so you have a knowledge graph, you apply some black magic, which is basically machine learning, and you are able to transform that graph. So your artificial intelligence transforms that graph into a set of nodes, into a set of points. Again, as you remember, because the computer understands points because it can compare how far they are. Computer is very good with vectors and points. So every one of these, so like Denmark becomes a point, Copenhagen becomes a point. And this was exactly what I showed in the beginning with the LLM. The question was, can I even trust that what the black magic has done? So this was black magic, right? So I don't know who created. OpenAI gave me an LLM. Is OpenAI doing good or not? We don't know because we have never had the chance to open up what was happening and what kind of data did they use. So in this work, for instance, and this is another way to see the problem, is we asked ourselves, look, can I trust every similarity? And for instance, I ask this very simple question. If I take one single data point, like Denmark, and I look around Denmark, just looking around in a kind of a bubble, can I say that what is around Denmark is indeed correct? And I will let my daughter say. My daughter was happy about that, and she was, oh yeah, oh, sure, of course. And then I asked, okay, you remember internet, the IT crowd, and the floating balloon? Seemingly, the LLM believes that these things are close enough. Is the surrounding of this reliable? And this was the answer of my daughter. So my daughter is actually making a better job than what the LLM did. So, but can I give, as a scientist, so if I want to give to the world something that is useful, I ask myself, okay, can I give something that tells me, a number that tells me, okay, around here, I'm happy, around here, I'm not. Again, just a tiny little bit of technicalities. How do these works do? Well, they have a sort of a score. In the case of large language models, you have a kind of a probability that once you see something else. You can think it as in terms of a score, So it spits out a number. And for instance, if, and they go back to the data. If in the data, Denmark capital Copenhagen exists, then the score should be high. And if so for instance, Denmark capital Inter does not exist, the score should be low. This score changes by method. But this is not the point. I don't want to go for a specific point. I don't want to go for a specific method. I want to go for all the methods. Well, this translates, again, and this is something that we can learn in computer science. We can actually look at the distribution. You can look on how many of the positive ones, so what are the scores, the scores of the positive ones versus the negative ones. And we can see that since the model, the machine learning model that produced these embeddings was trained using the score, I expect that basically if the score, many scores are high, if we have positive, so if we have a factor, a triple that exists, and low otherwise. Now, I can see that I don't have so much time, but then I'll go very fast forward here. Well, the idea was the following. Do not use the score as it is, because I don't know how that score, what that score means. Again, I treat it as black magic. It's black magic for me. I don't know what that score means. I know that it exists. And I know that if I ask that specific machine learning model to give me that score, it will give me. So I can actually compare the relative position. And I say, okay, Denmark located in North Europe, and I look around. Again, that's why I said look around to Denmark. And I look around to other possibilities. And here I create all the possible negatives that exist. So for instance, Denmark located in Copenhagen, Denmark region of Copenhagen, and so on and so forth. If I see that this positive is very up on the ranking, so I just order by score, sort by score, then it means that around Denmark, we have basically that everything that is positive is indeed positive and everything that is negative is indeed negative. But this doesn't happen everywhere. So in some parts, this Denmark located in North Europe can be very low in ranking. If it is very low in ranking, then this reliability score, basically the ranking is basically this number here, is the position in this ranked list. This score will be low. And this is what we had, basically. And you can do it for other ones, and then you can see how to compute it. Okay. Now, the problem is the following, that to compute this, we have to do very complex operations. So we have to basically construct all the possible negative in the world. Well, we can avoid doing that by being smart. Instead of taking any single of these negative triples, so triples that don't exist in your graph, we take a subset, and that's good enough. Basically, this is what these approximations are, and you can see that it's good enough because the error of the approximation decreases very faster if you take, for instance, 20% only of the negatives. Cool. Remember rule mining. Is this also a good tool for rule mining? Well, seemingly it is, right? So is this score good? Well, if we take all the negative instances, remember that we have marked, labeled manually all the positives and all the negatives. If we take all the negative instances, then we see that this relic score, this is what we call the reliability knowledge graph score, is low. If we did positive instances, they're high. On the other hand, if we take a score that already existed, that was used for evaluation, this is not always the truth. It is very confusing. So, yeah, if I have to do a bit of if I have to sell my work, I say, look, this is so good, blah, blah, blah. In any case, I want to go a bit faster here because I think we also need to wrap it up. And again, when we do experiment, I'm an experimentalist, right? So I'm not a theoretical computer scientist. So we do a lot of experiments on data because, well, I'm a data scientist in some sense. I'm a data analyst. So what I do is I prove things on the data. And again, we need to prove with respect to random. We do need to prove with respect to some previous baseline. So we need to basically just oppose the results of what we have. So what is the take-home message? So one of the things that I teach my students all day long is check your data, know your data. Do not rely on machine learning and artificial intelligence as it is, because it will not work. It will not work. It has still a lot of problems because the data has problems. So it is important for us to be able to analyze the data. And this is what we teach. So at least in my group, we teach that. And we also teach how to do it fast. So how do I can perform very complicated analysis fast? In my specific research, I do tackle this, but I also teach these techniques. Of course, not these super advanced techniques, but I think it's actually quite a lot of things to learn and to have fun and to play with. So curiosity, I asked about myself. So I worked on this funky problem, graph alignment, and I asked ChatGPT, can you provide some references from researchers in Denmark? And my name didn't appear. That was, again, very, very disappointing. Okay, I want to leave you with this teasing here. So check your data and enjoy somehow the ability of being able to do analysis. Okay, this concludes my talk, and I'm happy to take any questions.
Perfect. Wow. Thank you so much, David, for the very comprehensive, because I'm really excited. And I believe that a lot of participants here is also an AI enthusiast, right? So this is really amazing about the AI, the technology and everything. So, okay. I just get it that the interesting point that I got from you is about like, do not rely on the machine learning. That's a really beautiful quote, actually. Yeah. Right, because I'm just like keeping frustrating with my data too, like when I'm training and then it's still getting wrong and having lower accuracy, so that's still like a problem, right? So that's really good quote for knowing the whole, yeah, on the machine learning itself. All right, okay, so now we are going to open the Q&A session. Actually, we already have some bunch of questions already in our Q&A box and also in our chat. Maybe we can just start from the Zoom chat first, because that's the very first question that we already got. The first question is about like from Muhammad Zakir Zipi. This is like, is AI will positively impact our world while adapting the trends of the 21st century?
Sorry, I didn't hear well. Is it in the chat?
So, yeah. So, like, it is about like, is AI, the artificial
okay.
positively
I see.
Yeah. Maybe can you elaborate more on that, Davide? What do you think?
I believe it will positively impact, right? So this is an amazing technology, and I started from the beginning as it can give you a recommendation, it can help you speeding up writing, right? So you can use it for refining what you wrote, to summarize. So to some extent, it can also suggest you code, and I emphasize suggesting instead of writing for you code, because you need to check it. So it can, I think it can speed up a lot of different discoveries. For instance, I've been working with biological data, and in drug discovery, where there is enormous costs and a lot of people in need, I think actually AI would help a lot. But we have to use it with a grain of salt. That's basically my take.
Yeah. All right. So we need to be careful also, yeah, for the things that we are working on with the machine learning itself for the AI, it's actually have the positive impact, but still we need to do something on it, right? All right, thank you. All right, I hope that's really answered the question. And from the Q&A box, from the Venkateswaran Bala, is there a possibility of deep fake in AI? And if so, how to find it? That's really interesting, actually.
Oh, that's thanks for the question.
Yeah, the deep fake one.
They do exist, right? They do exist already. With some, so you can see talks of the president of the United States that never did it, right? So that's this generative AI is very powerful, and if you're not careful or you're not paying attention, you might be fooled, right? And that's spread of information that I was talking in the beginning. So how to find it? Well, this is exactly where government and research and us computer scientists should work on, right? So that we should also, at the same time of giving AI methods, we should also work on methods that actually detect. And how do you detect? Well, basically, one way is to use what is a real talk, and that's basically what is, if you are comparing a talk of someone, right? And then the one that is generated has still a lot of regularities, because a machine learning model cannot really capture everything. And it captures especially in things, so machine learning models are very good on average cases. What does it mean? It means that they are very popular and that they are repeated and so on and so forth. They are not very good in edge cases, in places where something surprising happens, or maybe the modulation of the voice has never been seen before. And that's what happened also in my question, right? In the when I asked ChatGPT, or when I asked ChatGPT even about myself, it didn't have the data, right? So, and that's where, so if it doesn't know something, it will craft out something, but you will spot it. So it is important, though, as researchers and as computer scientists, to work on explainability, to work on reliability, to work on robustness of these methods, so that we have also method to check whether there is a possibility that it has been generated by AI. But they're getting uncannily good, right? So that's there exists and they are there.
Yeah, we need to be aware of that, actually. And of course, especially if you are going to like becoming the researcher, and then also specifically about the AI, this is something that we need to consider first, right? Is that correct, Davide? This is my opinion. Okay.
Yes. No, I agree.
All right. So the next question, this is about like the preface that you already mentioned in your presentation, Davide. This is about like the ChatGPT-4 and also the Gemini and also the LLM, which is the larger language models. And there's like 3 different things, or maybe 2 different things, the ChatGPT and the Gemini. Do these kind of tools use of the same transformer architecture? So because you said about the transformer between one of the another, and this is the thing that he is asking, or does the model change from AI to AI? So this is interesting too.
That's a very good question again. Yes and no. Okay, so and in the back, so in the very, very back, it is a sort of a transformer architecture that we know it works well. But there is a lot of engineering, so it changes quite a lot, and we don't have the details from these companies, unfortunately. So many of these models are not disclosed. Llama is open source, and the back is still it is a transformer model.
Okay.
But then in the transformer family, there are a lot of variations, right? So it's not only one single thing. So there are a lot of ways to make it faster, to skip connections, to reduce the number of weights. But there is really a huge amount of engineering that goes to design these models. So as I said, I believe that currently most, I cannot say with certainty that all of them, but most use the transformer architecture. But they have also some modifications inside, so they have their proprietary modifications.
All right. So it depends. Yeah. Sometimes it's disclosed, but again, still has the same kind of design in the behind. Is that correct?
For now,
What I get.
yes, because it's the one that works the best, basically, for what we know. But there are a lot of research that actually pointed out that it's not necessary to have that. So we will see more and more in the future, right? And it's an exciting time, actually.
Right. So there are still a lot of research happening, working on that field, yeah, Davide.
Sorry?
So there are still a lot of research that working on that field,
Yeah.
Right? And we'll see later on, maybe some years too. Yeah.
Absolutely, it's incredibly large. So it exploded. It's going to any machine learning conference nowadays is like being an affair of research in various directions. And of course, there are the various directions works in making them more solid, in changing the model. Just lately, a new architecture, completely new, came out, and it's already it's called the Kolmogorov-Arnold's networks that came out and said, okay, look, we have done all this research on neural networks, but nobody objected that we could do it in a different manner. And of course, they keep coming out. So it's it's exciting, and at the same time, it has to be. Well, this is a message for governments mostly. They have to keep up, and it's not easy.
About the security and stuff. Okay. All right.
Yeah.
And the next thing, maybe I will give the opportunity for the participant, if you are going to ask live, like open your mic. If there are any participant that you are going to ask live, just raise your hand and I will open your mic from there. Okay. While waiting for the participants that want to ask live, let's just continue from the Q&A box. It is also interesting one, and I also wondering about the answers. So, what books that would you recommend on this topic specifically?
Okay. Well, it depends if you're looking for advanced or basic. So there is the traditional deep learning books from Goldberg, I believe. There is a lot of data mining books, so from Zaki Meira, for instance, traditional machine learning, traditional or more fundamental machine learning from Bishop or Shai Ben David. It's called Understanding Machine Learning. These are all fundamental books that I would actually tell people, start with those, right? So they're really great. And then, of course, there are more theoretical stuff. And then there are more modern books. I have to be honest that I haven't surveyed the really last ones. I know that there are some that about transformers, at least, so that they're. But most of what is happening about transformer is in video lectures. Google is providing a lot of them. If you want a very high-level introduction that tells you how they work, there is 3 Blue and 1 Brown that does on YouTube amazing videos to explain complex concepts in a very simple manner. All the major universities provide courses, so Udacity and all these kind of things. Some of them, unfortunately, you have to pay, but a lot of material is available. So I would start from basic books, but because they're more consolidated, this is my answer. But there are a lot of books that currently I'm not on top of that can be used. So, for instance, for the stuff that I explained, the representation or graph learning is one of the books. Geometrical deep learning is also very nice, and it's a different perspective from deep learning. There's really plenty of material.
Wow, a lot of books that we need to learn, actually. All right, cool, thank you. So let's just continue because there is no one that raised their hand to ask a question live. The next thing is, does data analytics or business analytics master program undertake this topic as course? Or maybe, I don't know, can you elaborate more on this answer? Yeah. Does data analytics or business analytics master program undertake this topic as course? What do you think?
Some part, yes. So at least the introductory topics, yes. The more advanced stuff that we have seen is mostly if you do for. So okay, one answer that I can give is also that one way that the students learn these topics is by doing master projects. So with one of the groups of the research groups, and then you learn that these are more advanced topics, because what we need to teach is basically the basics so that everyone are on the same page. Once you know the basics like data mining, machine learning, we are currently hoping to have in the future something a bit more on NLP, so natural language processing and transformers, all these kind of things. But we don't know yet. My dream is to teach graph mining, but the more advanced stuff, not the one that is basic. So there is really a lot going on. Currently, we have the introductory course. We have data visualization, data mining, machine learning. We have also, from the theoretical point of view, cluster analysis, learning theory, statistical learning theory, and a lot of them basically, and all of them are interrelated, right? So what I'm talking here is a lot of disciplines that come together. So there is not a single course. There is basically a lot of different courses that we provide.
All right. Wow. So the basic and the fundamentals come first, yeah, as you said before, David. All right.
Yeah,
cool.
that's unavoidable.
Yeah, unavoidable. Agree. Okay. And the next question is really related to your presentation. Wow, this is cool. Like the question is, what is the meaning of part 2 in your presentation? I don't know where exactly this word is. The meaning of part 2 in your presentation. Could you tell me about the connection about the chemical engineering and data science, still linear for study and prefer not use AI? Maybe we can answer the first one. What is the meaning of the part 2 in your presentation, David? I don't remember where exactly the word is actually.
Is it?
That's
let's see what. I'm not sure if part O.
Part O.
Let's see. I have also to remember because I don't remember exactly. Oh, that's the problem that I have.
Yeah. Or maybe Prita Arianti, can you open your mic and elaborate more about your question live?
I'm trying to find out where there was. So if I used.
Yeah.
I can't really find, unfortunately, but I can answer the second one at least. So the connection about chemical engineering and data science. Yeah, so there is a lot of resistance also in using AI, and I totally understand, right? This point of view. The problem is that the AI has still a lot of problems, and then once you have to give, for instance, some recommendations for a chemist, and you are not sure if your machine learning model is actually doing a good job, that's a problem. But I think what we need to do, and this is what I'm also spending a lot of time, is to talk a lot with different domain experts so that we can actually build, as computer scientists, algorithms that are better for their use case. And another important thing that I learned from working interdisciplinary is to provide explanations. So you cannot just give results of a machine learning model. The machine learning model needs to tell why there is a certain things, why there is a certain prediction happening. I think there is a lot to gain in the interplay, for instance, in chemical engineering, in this case that you brought up, and machine learning and artificial intelligence. But we need to have the will also to communicate with each other and to make more interdisciplinary projects. I'm very happy actually to make them, they take a lot of time. That's the main problem. That's why often we do our own research, we do our own product. But nowadays, many companies are coming out, right? So with at least the things that were not thinkable before, like drug design, biomedical applications, and all of them are involving AI. Inside, they have people that have, some people have medical expertise and some people have AI expertise, and then you just work together.
Right.
I
Okay,
don't know
I
if
think,
this answered the question. Yep.
yeah, I think Prita Arianti already here. So maybe Prita, can you elaborate more about your question regarding the first question actually?
Thank you very much for the time. I want to asking about the data science and chemical engineering is more better for research or course. Kan there are two type of two. If I want, kan I have been study finish in the bachelor degree of chemistry education, but I want to go to the master degree in chemical engineering. If more better if I use after I see the presentation from your the last time, I want to know about the more better if still use the AI, and then more better for the chemical engineering for the coursework or for the research. If is prefer if you if more better use AI or not gitu, like that.
All
Thank
right.
you very much.
Okay, got it. So Prita is come from chemical background, right? So she is asking which one is better to take for the study. Is that in chemical engineering or data science? Or yeah, maybe you can just elaborate more on that. Which one that gives more now nowadays situation?
That's a very good question, but I don't think I have a comprehensive answer, at least. So my intake is with the chemistry background and interest in data science, it is worth to invest time in a master in data science. However, if you want to deepen first, so to go first to chemical engineering and maybe deepen some aspects, especially of chemistry, because I expect that chemical engineering has a focus rather, so specializes basically in some aspect rather than others, then on the side, you can always study the data science. The other option that you have is that you basically, but it depends on your time and how fast you want to be, is also to take two masters somehow and take something that is in chemical engineering. And it is not unheard that people actually do a second master in computer science, data science, afterwards. So ultimately it depends on you. Do you want to deepen your knowledge in chemistry and specialize in a specific area, or do you rather want to use what you know about chemistry and then being able to apply to data? That's the question, right? So that I cannot answer. But it's true, chemical engineering, if you go for chemical engineering, I doubt that you will find data science inside. Right now, for the current, at least, programs that are out there. Of course, I don't know all the universities that is true, but there might be some interdisciplinary. You can go for something interdisciplinary. So the biochem, I don't know, chemical engineering. I have no idea actually what would be. There is definitely bioinformatics, but that's not relevant for what you asked.
But maybe if I can ask, I can add, if maybe, for example, I take the data science and then I want to apply the data science in my specific study case, for example, chemical engineering. Is that possible to do that? That's my,
yes.
I don't know, just wondering about it.
Yes, I mean, I've met quite a few, at least PhD students that after doing chemical engineering, they're currently doing data analytics. And in that regards, at least in Aarhus universities, but I've seen in many universities that are preliminary course of data scientists for PhD students in other disciplines. And then you start, for instance, using some small tools like Python, like a bit of data analysis, and then you show. Of course, it is basics, right? This comes back to: do you want to specialize deeper in a data science methods, or do you want to first specialize in your discipline and then go to data science? Both are valid paths.
All right. Okay, I hope that's really answering your question, Rita. Okay, we have more two participants here who raised hand. Maybe we can start with Emmer Abasi. Hello, Emmer. Yeah.
Hello.
Yeah.
Hello. Are you hear me?
Yeah, I can hear you clearly. We can hear you.
Okay. Okay. Good evening. I have a question regarding AI.
Mm-hmm.
Basically, I'm a student and I'm interested in research. And yesterday I tried to analyze my time series in AI, but I couldn't get my results. So my question is this: can I analyze my time series data in AI? What would be the easiest way to analyze data in AI? And now the second thing is, it's my perception that no doubt AI is a innovative and latest technology, but I think it's also very destructive for students, because students try to support AI instead of trying to learn themselves. And what is your opinion regarding that? Is it good for student for learning purpose, or it's easy going for students? Thank you.
All right. Got it. We have the question from Amirat. The first question about like, is there any easiest way to analyze data in the context of the MR? Easiest way. I don't know easiest way because there are many ways.
That's a good question. Okay, the easiest way, and this is what I tell students several times: use the easiest methods, right? Those the traditional ones, before going to more complicated AI machine learning methods. So start with the data analysis that is already known. So for instance, exploratory data analysis, if you have a time series, periodicity, so there are a lot of methods that finds out periodicity patterns and so on and so forth in your time series, right? So you can see how many times it happens that a specific burst happen. So you can find anomalies, you can find a lot of things with very traditional methods that are much easier to understand. Now, the question was also that you have that if you can use AI off the shelf in some sense, right? So that you can plug AI and it will work. No, often no. So there is a huge amount of engineering. So even for us, which we are experienced in working with these tools, the first attempt doesn't really work, right? So we have to really work a lot and think, okay, what can we fix? Why it is not learning? Then there is the other problem. Do I have enough data, right? So because when I use like these transformer models, but let's use a much simpler method. So you can use an LSTM or on a recurrent neural network. So these methods are data hungry, right? So they require a lot of data. So if I don't have enough data, they will not work well. That's why I go always for the simple one, because the simple ones can give me some good results. And then I can use the simple ones even as an input for the more complicated ones. And typically they boost the performances. But of course, it's a very generic, I understand. I cannot give you the specific answer, but don't get discouraged if you don't find results with machine learning methods in the first attempt. It will require time. And the second question was
The students, like, what is your opinion for the students to learn from AI? Is that better for them to learn from the AI, or just learning by themselves is much better for them actually in this era?
Is it so? Is it fruitful or it is destructive for students? Because mostly students in previous era, mostly students who try themselves to get results, and they may struggle for that. But through I think they are easygoing. And what's your opinion about that?
Yeah, okay, you touch soft spot here. What I generally recommend is learn the basics, learn how things works, because the specific tool will change, right? Now there are transformers, tomorrow there will be another things. If you know exactly how the overall idea works, then I think that's I think the value of universities or courses, right? You can learn by yourself. Of course you can. I'm not saying that university is the only way to learn, but there is an added value, which is basically that the university try to structure the program in a way that you learn progressively and you learn the basics first. Learn the basics. It's like first learn how the tool is made, and then you can change the tool as you like, right? So it's true. Nowadays, you can, with 5 lines of Python, you can build a machine learning model. But do you understand what is going on? So are you understanding actually what is going on? That's for me the main difference. And no matter if you go to a university or not, try to learn the hard part of how does it work. That's, I tell the students countless times, because sometimes they are, oh, I have tried this. No, you don't have tried this. Why did you do that? So for me, the why is much more an important driving force rather than the I program and it works. But of course, for AI also, it requires a lot of experience, right? So over the time, you need to basically try a lot of different things. And some of the things are not things that you find in books nor in universities.
Right. So we need to be adaptive too, yeah, and also preparing for the best
I have
fundamental
last
strong.
question.
Okay.
Ma'am, I have last question. If you allow me.
Actually, I'm so sorry for the time
For a few minutes,
limitation, Emmer.
for a few seconds, only for a few seconds.
Okay, last
If you allow.
question, maybe, Emmer.
Yes.
Yes, last question. Yeah.
It's okay. Can we evaluate or can we test citation citation of AI? Because I found that those citation which I got from AI, when I tested, these are not authentic citations. So how we can check citation that whether it is authentic or not?
Use traditional things, of course, and that goes back to my talk. Very short because we have little time. Use traditional digital libraries, DBLP, Google Scholar, Microsoft, and so on and so forth. They are repositories of so publications are by definition public. Archive also. So check if they exist. If they don't exist, they are likely they don't.
Right. All right. Thank you. Okay, that's actually become the last questions that we have in this Q&A session. Unfortunately, sorry for every question that hasn't answered yet. But again, we will take notes of your any answered questions in this session. And yeah, sure, yeah, I will get back to you to a follow-up email after the event. Okay, once again, thank you so much to David and also Sarah from Aarhus University for the presentation and also the insight with the answer of every question that we already had in the session. Again, give applause for Davide. Okay. Again, before we close the webinar, I would like to ask for your feedback to help us improve better. Please scan this QR code here, or maybe you can click the link sent in the chat box to give your feedback. We're waiting for you, and we're waiting for your feedback. Your feedback really matters. Again, but one more thing, the important thing is you need to fill out this feedback form to get a certification for joining the session. I've seen like a lot of questions asking about the certification. So just fill out this feedback form first, and then in 1 to 2 weeks after the session, we will send you the certificate. And also, we will send, don't worry, if there is something not bad, something bad in your connection, we will also send you the presentation file and also the recording file of the session. So following with the newsletter information from Aarhus University. Once again, for those of you who are interested in studying in Denmark, but don't know where to start, don't worry, we got the solution. Just join the student community in our Telegram channel. And also in that channel, there are also a lot of people who share the same aspirations to study in Denmark. So just join the channel. And also you can get the most updated information, steps, tips and tricks maybe from the students or the current students, absolutely. And also alumni of the Denmark University. But again, if you would like a personalized consultation, Étude Edu Indonesia also provide a drop-in consultation where you can ask anything related to your study. Our professional consultants are more than ready to help you. So just don't forget to keep contact with us. And I want to remind all of the participants that we still have our upcoming mini class on 28 June with the topic Studying Multilingualism, Speech, Language, and Communication in Ireland with University of Galway. Make sure to register yourself in a link shared in the chat box to save your seat at the event. We finally come to the end of this webinar. I'd like to thank all the speakers, David and also Sarah, for the informative and interesting presentations, and all the participants for their very active participation. Of course, on behalf of EHEF, Étude Edu Indonesia, and our speakers, thank you for joining us today and see you in other events. And one more thing, don't forget to register yourself to EHEF consultation too. See you and goodbye.